I hope you're able to see my charts. Um, it'll be good to actually get a background of the people who are there in the room, even though I may still not talk relevant stuff, but I'll try to be as close to what you guys do if I have some insights about what is the background.
Hi, I'm Deepika and I'm in junior interaction design.
I think, yeah, I mean, I think what I need is like at a high level, maybe if Deepak, you could summarize about what are the kind of programs that people are from. That should be enough. Yeah.
Yeah, so the students are basically from design background with specialization in interaction design, product design, and visual communications. There are
Okay.
some students. I'm the only the PhD student, and RAs are also there, research associates.
Okay. Okay. I see. Okay. Sure. So honestly speaking, this talk is mostly about what I perceive. I mean, I know less about design than you guys, definitely, but I know more about machine learning and AI. That's what I have been working on recently. But having some touches of design that I used to do when I was at IBM, what I feel is that there is a lot of implication of design changing from standard design processes to how design should be looked at in the when people are starting to build AI systems. And there is a lot of there are different kinds of implications about how do you actually design systems which at the back end are running AI systems. And that is what I wanted to highlight through this talk. And so let's see how it goes. Okay. So yeah, at a high level, the focus is simple. Um, you are going to do most of the part, and I'm going to just see and understand and observe what you guys do, and then make you guys think about how you should solve these problems. So I'm going to give you some case studies and some examples and some anecdotes and see how you react to it. And then I'm going to raise questions about, and I can touch a bit about what are the design implications of things that you see and perceive that you would do in this session. And then the how part is completely up to you, maybe something that you can take away after this talk as to how, because you are the guys who are smart in this space, so you would figure out that how should design approaches be changed when you look at what you would have gone through the why and what part of things. So more or less what I'm saying is that it's all yours. All right, so um, I want you to do some exercise out here, and don't tell me the answer right now. But when I ask you, just tell me the answer. But for now, just have a look at what you see on the screen. All right. And then have a look at this. Yeah. Now tell me, what did you see in the first screen? Have you guys had breakfast? I can't hear anything.
Shock.
A girl.
A woman was
Sorry?
shouting or scolding someone.
Okay, okay. So let's do this in the other way. It's hard to do this in an offline manner. So raise your hands if you think that it was a black and white image. Okay, raise your hands if you think it was a woman. Raise your hands if you think it was a angry woman or a surprised woman. Yeah, and this is just my way of waking you up to just raise your hand. Everyone is raising hand at everything. Okay, so now don't give me an answer. All right, I don't see any hand raised.
So,
And why did that? Sorry?
so we lost the last bit. Like there is a connection issue. Would you please repeat what you said again?
Okay. So I just said that raise your hand if any of you solved the next screen problem, which was 17 multiplied by 24. Don't give me an answer, but raise your hand if you actually solved it. Yeah? If you forgot, this is what it was. All right. So now pause for a second or a minute and think why this happened. Everyone had raised their hands when they saw that. I mean, when I asked whether it's a woman, black and white, angry woman, and so on and so forth, right? None of you solved this. Why is that? Okay, let's do this. Why don't you guys solve this? Everyone in the room needs to solve this, and then we'll go forward.
So what do? We tell you blurt out the answer or what?
I mean, is everyone done?
How many people are done? We can ask that.
Anyone who's not yet solved this, please solve it. Only then I'll move forward. I don't have many slides, so I can wait as long as you take.
I think they're done. Anybody is remaining now?
Everyone done?
Yeah.
Okay, cool. So, I hope all of you know that the answer of 17 multiplied by 24 is actually 406, and that's what you all got, right?
Oh,
Okay, that was a bluff question. So, you really solved it. That's good. So, but let's come back to the same question that I was asking earlier. Why was it that everyone had an answer when they looked at an image and actually no one even attempted to solve this unless I forced all of you to solve it? When I had forced all of you to solve it, not everyone would have been in a mood to solve it. Still, when forced and asked, and I kept on waiting, and then eventually you solved. Why does this happen?
Cognitive load.
Okay, so cognitive load is more in 17 multiplied by 24. Is that what you're saying?
I think people are more open to analyzing visual cues. So the questions about the woman's picture were apparent. This required some people to actually calculate something, and people are reluctant to do that.
Okay. So let's get deeper in this actually. So what happens is that there are actually two parts in our brain, and this is a very nice book, Thinking Fast and Slow, which actually says that one part of our brain thinks very fast, and the part of the brain which did that calculation is a completely different part, and it is its property that it is very slow. So the part of the brain that looks at images, visual cues, sounds, and so on is a different part. It is very fast. The other part of the brain, which has to do these calculations type of stuff, is very slow. And that's the reason it happens not with you, not with someone else, but with everyone. Whenever you show them these two things, one part of the brain processes things faster. The other part of the brain, which is required to do the calculations, is inherently slow. It is designed to be slow. And this is what these authors, in some sense, harped upon in this particular book, and I'll tell you more about this book. But let's get back to your brain. We are not done yet with respect to understanding it. Yeah. So now what I'm going to do is, how do we do this? So I would want half of the people, and you guys can decide which half. Half of the people I'm going to show you a video, and I want half the people to just look at the video and do nothing about it. Maybe people on the side of Professor Joshi, because I don't want to trouble him a lot. And the people who are on the other side of the table, I want you to look at this video and give me a number. This number is the number of times people wearing a white t-shirt are passing a ball to other people who are wearing a white t-shirt. Yeah, understood? So this will also come in the description, so you'll understand that. So one half of the people need not count, please. The other half only does the counting, and you figure out which person to the left of whom everyone does the counting, which person does not do. So let me start this video now. All right. So any answers on how many passes were those?
14, 15. I got 15.
14, 15. Okay. So please raise your hand if you did the counting so that I know who did the counting and who did not. All right. So now those who had raised the hand, who did the counting, raise your hand if you actually saw a gorilla in this video. One guy. Okay. On the other side, those who did not do the counting, can you raise your hand if you saw the gorilla in the video? Okay. Everyone is in the same room. Everyone is watching the same video. What is happening here? Let us look at this video again and then I'll tell you what is happening here.
The correct answer is 16 passes.
Well, this answer does not matter, but this is the main
gorilla?
thing. So just watch this video again. I've just paused at this moment. Look at the curtain color. It is red here. And then the gorilla comes in, does some action. And look at the color of the curtain. It has changed to orange. And the gorilla goes back. Earlier there were 3 ladies in black. Now there are only 2 ladies in white. So not only did the people who were doing the counting miss the gorilla, but also actually the people who were doing lot of people would have, if they had seen the gorilla, someone would have missed the change of the color, someone would have missed the black woman going away, right? Did anyone actually see everything, which means the black woman going away, the gorilla, and the change of the curtain? Please raise your hand. No, right? So there are a few implications of this video. It is used in a lot of studies. What it says in one area where it is used is how much do you believe in eyewitnesses when you are making a judgment in a court of law? Everyone in this room was actually watching this video, and that's the only thing you guys were doing. So you were very attentive. It's not that I am cycling on the road and then I see a murder and so on, right? My main activity was to see the video. Still, I missed out on this, clearly this gorilla guy. So then this video is actually used in instances to show that you cannot completely depend on eyewitnesses because our mind fools us a lot. We might be concentrating on one part of the screen and we really miss out on the main activity. The gorilla might actually have been killing someone, or maybe the gorilla had a gun in his hand and you wouldn't even notice that, right? But the reason I wanted to talk to you about this video is that to bring back to the same thing, that there are 2 parts in our brain. And what you guys did in the first activity was that you guys said that one part of the brain was slow and the other part was fast. But in the second activity, what you guys did was that when one of you guys were counting, or some of you guys were counting, you were using the second part of the brain which does the multiplication, which does the counting. So when you were doing that, the other part of the brain which does looking at things and so on, hey, can you just give me a second? I'll have to take this call. Sorry about that. Yeah, when the part of the brain that does counting or multiplication and so on, when that is active, the other part of the brain is actually not working. So when one part of the brain works, the other one does not work. You missed out on the gorilla, you missed out on the curtain because you were busy doing the counting. So not only there are two different parts in our brain, but actually when one works, the other one does not work. That is what you have proved, right? So the part of the brain that does looking at things like a gorilla or the woman and so on is extremely effortless. I didn't have to ask you, I didn't have to do something. You just sat there and said it's a woman and so on and so forth, right? It is probabilistic in nature, which means maybe it is not a woman. You can't be 100% sure, right? And how did you arrive at the fact that it is a woman? Any thoughts? Did you look at the size of the hair, or did you look at the eyes? Did you measure the lips? What did you do to say that it is a woman or it's an angry woman? Hello?
Maybe the size of the head, the absence of facial
Any
hair.
answers?
Can you hear me?
Can you hear us?
Oops. Hello?
Yeah. Can you hear us?
Yeah, now I can hear you. Sorry.
So probably the size of the head, the absence of facial hair. Um,
Okay, nice. Okay. Honestly speaking, the reason you could arrive at this decision that it is a woman is because you had seen many faces of women earlier, and you could identify that this is a woman rather than a man. You had never done any calculation of the length of the hair or the facial hair and so on. That's what you are trying to fool me by saying that these are the methods that you looked at. But usually, what happens is that we have seen too many faces and therefore we arrive at that decision. So, this system one part of the brain, which is what is called in the book, I'm using the same terminology, is actually completely data driven. On the other hand, the other part of the brain, which they call system 2 in the book, which does these kind of calculations or which does these kind of counting, is extremely lazy. And you had proved it, right? You didn't do that 17 multiplied by 24. It is very deterministic. I could not argue with you the fact that the answer is 406. Everyone there said that it is actually 408, right? On the other hand, I can argue that this is a woman or not. If I ask you a method, how did you arrive at this decision of 17 multiplied by 24? All of you would have an answer to it. And that is a real answer, not a fake answer, which you were trying to give to me in the system one when you're trying to look at the image, right? So you know how to solve this problem. You know that 7 needs to be multiplied by 4, do a carryover, and so on and so forth, right? So this is completely method driven, right? There is, just give me yeah, sorry man, I need to take this call again. हेलो मम्मी मैं हाँ मम्मी मैं मीटिंग में हूँ मम्मी मैं मीटिंग में हूँ नहीं मम्मी मैंने उससे ऐसा कुछ नहीं बोला था मम्मी इतने साल हो गए शादी को ऐसे कभी किया ही नहीं है मैंने हाँ जी मम्मी मैं मीटिंग में हूँ बाद में करता हूँ हाँ जी बाय बाय So in this last 30 seconds, you all figured out that I have some problem and my mom is calling and there's something wrong with my wife and my mom and all that type of stuff, right? I was faking the call. There was no call. Okay. I wanted you to realize the fact that the system one part of the brain is very spontaneous. As soon as it listens to something or sees something, it automatically calculates or does all these kind of calculations and so on. किसकी मम्मी का phone आया, ये हुआ, वो हुआ, and all that type of stuff, right? It is extremely spontaneous. On the other hand, system 2 part of the brain is actually something that needs a trigger. I had to ask you that I'm stopping, you need to do the calculation and so on. So, right? Now, there is a bigger problem to this that you all know this guy, right? Alok Nath?
Yes.
So the challenge with, I'm sorry to Alok Nath fans if there are any in this world. The challenge with Alok Nath is that in any movie that he acts, he thinks that he is like the central hero, like the ladki ka baap who's going to make all the most critical decisions and so on and so forth. But actually, the real hero is someone else. And this is what happens, that we all think that we are very logical people. We take very method driven steps in our lives, and we take rational decisions and so on. On the other hand, the reality is that all of us take important decisions in life using system 1 part of the brain. And it is obvious because system 2 needs a trigger. On the other hand, you just saw the example how you would have reacted to the phone call, which I kind of took, so that you could automatically think of decisions and make an impression about me and so on and so forth, very spontaneously. So anytime when we have to take a major decision in life, the system 1 part of the brain, since it is fast, it would have done all the calculations and so on and so forth, and then you would come to a decision using system 1 part of the brain. But if someone asks you why did you take the decision, you would give very specific, logical, reasonable explanations. And this is not me saying, this is actually the reason why these guys, Daniel Kahneman, actually got a Nobel Prize. And the reason why he got a Nobel Prize for this work was that he said that this is their Nobel Prize citation. It says that they got this prize for having integrated insights from psychological research into economic science, especially concerning human judgment and decision making under uncertainty. So, when decisions are uncertain, that is when the system 1 part of the brain actually takes over. If it is a very specific certain decision, let's say how do I lift this phone, or how do I switch on the phone, or how do I take a call and so on, these are very specific decisions. If there are uncertain decisions like which college to join, which company, which job to take, which who to marry, which house to buy, these are very uncertain decisions, and they're uncertain because you're never sure about whether it is a right decision or not wrong decision. Let's say I'm sure you're doing good at IDC and IIT Bombay, but do you think it is the best decision? You cannot ever compare, because you can't be at two places at the same time and then compare A with B, right? You're only at one place, and then the other place maybe you could be something and so on, right? No matter how well you're doing right now, you might have been better at some other place and so on. The same thing happens with jobs. Nobody knows, is this the perfect job for me, because you have never lived the other life, so you will never know, right? So all these uncertain decisions, when it comes, they are taken by system 1 part of the brain. And now let me tie it back to the work that I do in machine learning and AI. What AI is trying to do is that it is trying to build machines which can take these uncertain decisions. And it is obvious because earlier all these IBMs and Microsofts of the world used to build machines that can take these deterministic decisions. Simple interest, compound interest, how to do that, calculation and so on, flooded the banks, and you had IT in all the banks, because then you could maintain all these records rather than manually writing everything, and these computer systems were good to make these deterministic decisions. But who were they replacing by building those systems? They were replacing the clerks of the banks. Who is paid more, the clerk or the person who decides whether to give a loan to this person or not? The person who makes the decision is actually paid more. So if you can build a system that can replicate this guy or that can replace this person, obviously there is this bigger margin for all IT companies, and that's why the whole IT world is flooded with helping humans who make uncertain decisions so that their performance can improve. And who makes uncertain decisions in these days? Lawyers, doctors, um, radiologists, stock market people, HR, who to hire, who not to hire, and so on and so forth, right? So all these uncertain decision makers, the people are building AI systems to, in some sense, help those people. The other example being, as you would know a lot about, are like self-driving cars, right? You have to make very uncertain decisions on what split second decisions should I take and what should I not take, and so on. And that's where self-driving cars are coming in, and so forth. So all of this AI is actually trying to replicate system one part of the brain. So it is important from a design consideration to understand how the system one part of the brain works, so that we can start building in or building designs or designing systems that are applicable to system one part of the brain. Until, let's say, 5 years from now, all the design or even the testing world was focused on the system two part of the brain. Now, since a lot of computer systems are coming which are AI enabled, most of the solutions that are being talked about are AI enabled. How do you design them is a completely different ballgame, because these two brains work in a completely different manner. So that's the main hypothesis that I wanted you to think about. Now, what I'm going to do is that I'm going to talk about a few applications that I have been involved in. These are AI applications, but they touch human beings, and there are some different design considerations that come into picture, which you should be interested in. Yeah. So this is the first example. This is the work that I had done when I was at my previous company, which was a parent company of a matrimony portal, jeevansathi.com, right? So there, the problem that we were trying to solve was that I, as a prospective groom, log into that site and create a profile for myself. So I have a photograph, I have some interest, I have a age, I have a location, I have a salary, I have a company, I have a caste, I have interests, and so on. And then I need to match all of this with a prospective bride who might be interested in me and who can be of interest to me. So it is like a product recommender system, but not like what you see on Amazon, but what you see in real human lives, right? Now, in India, you guys would know that, or maybe everywhere else, there's a lot of implication about visual preferences. And it turns out that maybe beauty for me is very different from beauty for someone else. And so what I might think as a beautiful person might not be beautiful for someone else. And same is true for other things like hobbies and interests and age and so on and so forth. So we built a complex hoopla system. You see its architecture, which doesn't make any sense to you, to eventually actually take all this data and figure out what is the best match in some sense, right? So we built this system, we deployed this system. It didn't work as well. And you know why it didn't work? Because we didn't know how actually users behave on that site. So a typical person, what it does is that when they log into a jeevansathi.com kind of a portal, trying to look for their potential spouses, or you may, I mean, these young age guys would understand and appreciate more of a dating site type of a thing, right? So when you log into a dating site, initially your expectation is really high, right? You really want like the Aishwarya Rais of the world. So you try to find them, you send friend request equivalents to them, and they never respond. And slowly you bring your bar down to I don't know what's the next number or whatever. And then slowly you come to the reality, and then you realize what you are, and then you start sending requests to people who eventually accept, and then you realize what's your aukat in some sense, right? Now, if this is how humans behave, if I would have built a system which says that this is what I am, so this is what I'm going to get, and if I start showing those profiles to this user on the first day, the user is not going to be interested. He'll say, I want an Aishwarya Rai. I mean, or whatever is this new age generation Aishwarya Rai equivalent. I kind of reveal my age when I give these examples, but anyway. So, yeah, so these recommender systems don't work as this. So what we did is actually by understanding the fact how human psychology behaves, especially when it is the system, one part of the brain, which is not logical, then we realize that this journey of user is very building the system like. So therefore, we realize that candidate applies to really top class profiles initially, and then middle class profiles, and then so on and so forth. And it comes to a stage wherein the user realizes that he is where he is, and therefore he starts sending um, requests to those profiles. And then he gets engaged into the platform, and eventually, yeah, they get married and all that type of stuff. But unless you realize that this is the path that I need to follow, you will never engage that particular candidate, right? So if you are building AI systems, then it's not good enough just to match one profile with another profile. You also need to understand this journey and how the psychology of a human being plays into the picture, and then incorporate that into building the AI system. So the architecture that I am showing you now is a completely different machine learning architecture than the one that I showed you earlier. This one is a sequence based architecture where it is looking at what is happening at time t1, t2, t3, t4, and then it is trying to figure out what needs to be done at time t plus x, rather than saying that these are the two products and let me try to match them. So design actually flows in deeper in a AI system because it affects how a brain works, and therefore we have to model the brain differently, which is what we machine learning type of people do. We model our brain differently because we have to replicate the human brain and then bring it in here. So it has a much more deeper connection rather than doing some visual design on the page and so on and so forth. Yeah. So this is one example. Stop me if there are any questions. Yeah, so I already talked about that. This is the design criteria for you guys then. Any questions?
So I had a question actually. So uh, the example that you gave is perhaps a typical example of how men think or how males think. Do you have? Is this a gender? Is there a gender neutral example of this?
So yeah. So while I said the example taking visual considerations into effect is a male specific example, but the same psychology exists in females as well. They may not look at visual preferences. Maybe they'll look at people, and don't quote me on this, but just giving an example, they may look at people who are of specific um, from a specific region or from a specific set of companies or from a specific salary range and so on, and slowly they'll go down to what their reality is. So the features may change, but the psychology of wanting to have the best in my life and then slowly realizing that what is it that I can actually achieve does exist irrespective of the gender, right?
And so, is that just an optimization algorithm of some sort?
So what I was trying to say was that you have to take care of the sequence in which the users want the site to behave. On day one, if I tell them the realistic expectation, they are not going to like it and they will never come to my site on day one. So I know that on day one, if this is a user and I'm showing the profile who are really on top, this profile on top may not be interested in this user who's so far down below, but I still show it to him so that he comes in the next day. and then I show him the lower profiles. This is actually also how brokers show houses to people. If they show the best house to the person in the first instance, that's how the expectation is set. So they would initially show 2 3 bad houses, and then they'll show a nice house. Some of the shopkeepers also do this kind of stuff when they are trying to show, let's say, saris to women and so on and so forth, right? So this is a standard thing. Um, so yeah, to answer your question, we have to actually change the entire model, because now we have to look at a sequence of events rather than just see out of this bag of 1,000 things which one is the best and then show that to the user. And modeling a sequence is completely different from modeling A to B comparison in some sense from a machine learning perspective.
Okay.
Cool. So if there are no other questions, let me move to some other use cases. I'll just quickly go through some of them, but come to the main point here. So at Mastercard, we are again focusing on making these uncertain decisions, because that's the part of the brain that we try to replicate, right? So I'll just give you some examples of projects that require such things. So what do you think is going to be the revenue for Mastercard for the next quarter? It's a very uncertain decision. It's not deterministic. It is data driven, because we can see how the revenue has been flowing in the past quarters and so on and so forth, and therefore predict a point in the next. So it is data driven, which is what system one part of the brain does. It is prone to error. It is not deterministic, and therefore an AI algorithm can solve that problem, right? But it is not deterministic. Can you predict when a server will fail? It is like trying to say that, can you predict when a person's health will go bad? So people start giving some indicators early on. Similarly, machines start giving some indicators, which they express themselves as logs. So can you look at these logs and learn and identify when a server is going to fail, so that you can do some preemptive things before that? This is the one wherein you're trying to. So Mastercard has this campaign called the Priceless campaign, wherein it gives a free ticket to Champions League or something like that to people, and but to people who are very socially well connected, so that they can tell about this experience to everyone else, and then everyone else also buys Mastercard. So who's influential in the society? So people who are influential in the society, if I give them that offer, then they will really spread the word around and so on. So how do you identify that? Again, an uncertain decision, which is what we try to do here, right? HR I talked to you about. So this is a job position open in the company, and there are thousands of employees. Who is the best employee who may actually fit this particular role? Or here are these thousands of employees in the company, which employee may actually leave the company? So these are uncertain decisions, but this is what we are trying to use AI for, right? When you make a transaction using your, I hope everyone has a MasterCard. So when you make a transaction using your MasterCard, our algorithms need to figure out whether you will eventually pay it back or not. Because if you do not pay it back, then MasterCard has to, this it becomes like a fraud kind of a transaction, right? So we need to figure out which transaction is fraud or not. This is also uncertain. How can we certainly say that you will pay or you will not pay? And that's what we try to replicate and so on, right? So from a design perspective, all of these uncertain decisions are trying to ask a question as to how would you come to this decision? And I'll come back to the same question which I asked initially. When you looked at this image, which is how system one part of your brain is working, what are the steps that you took to actually make this decision that this is a woman? Now, this reason becomes important, maybe not in this image case, but in cases where you are trying to solve these big problems. So when I say that the revenue of MasterCard is going to be X%, the stakeholder is going to ask me a question, why do you say that? And since I know that I have solved this problem using system one part of the brain, I have no idea why I'm giving this answer. So I need to make up an answer. which is where design comes in. So tomorrow, if someone asks you, why do you think that this is an angry woman, you need to come up with a believable answer. At the back of the mind, everyone knows that you just came up with this answer in a snap. You never looked at the length of the hair, you never looked at the eyes, you never looked at the contour of the lips and so on. It just came to you. But that is not what you can give as an answer to a people. So, what is the best answer that you should give so that the other person is convinced that you seem to be looking smartly? As an example, in this image, if I say that um, I looked at the background of the corners and they look white on the top and black on the bottom, and therefore I concluded that this is an image of a woman. If some algorithm is going to give you this kind of a reason, then you will say that this algorithm doesn't know much, and therefore you won't believe in that algorithm. On the other hand, the answer that one of you gave, saying that I looked at the length of the hair and no facial hair on the face, looks like that person is learned and he knows that there is no facial hair on a woman's face and so on and so forth. Had someone said that the eyes look more rounded and so on, maybe the eyebrows look like that or something like that, right? So if you give reasons that make you look more intelligent, then the decision, which means that this is a woman or not, is more acceptable to people. And this is a big area from a design perspective, that now when these algorithms are coming up with some difficult answers, what is the reason that you're trying to associate to them? Within the AI world, we are all trying to figure out ways to provide what is now called as explainability in AI. So what you see is on the right hand side are all the algorithms that are being now used to give an explanation or force an explanation. And the left hand side are some old logical based algorithms that are being used to force an explanation. The reason I'm saying the word force is that we still have our algorithms which try and replicate the system one part of the brain. We just give an answer in a snap, and it's hard for them to say why these answers have come. And then we are using all kinds of reasons to algorithms to come up with reasons. There's a huge implication of design in here, because designers can actually influence what reasons would be more amenable to users and what reasons may not be, and therefore design needs to play an important role in coming up with explainability within the AI domain. Yeah. And then the other thing is that once you know that these are the reasons, what are the reasons you convey to a user? Because you need to convince the user that yes, the revenue is going to be X%. Yes, this person is going to leave the organization. Yes, this is the best job for you. So you have to do that selling. How do you identify what is the best way to sell the job? And there is this whole area about persuasion, and there are persuasion strategies which had been there. I think there is some I forgot, there's some 6 principles of persuasion which you guys may know of. Does anyone know of those 6 principles of persuasions?
No,
No.
Yes.
no, no.
No. Oh, okay. Um, that's a that's a complaint to Professor Anirudh. I forgot the name. There's some guy who had said that there are these 6 design principles of persuasion. One is, let's say, something called a scarcity. So you say that only 3 things left, buy it quickly or something like that. The other one, I forgot the name, but it is like saying that 40 people in your network have bought this, so you also buy it. So social angle and so on and so forth, right? So now, how do you persuade a person that my AI? How does an AI algorithm persuade those decision makers that this is the right decision? So that is a big area in some sense that is going to come up and is coming up within your design space, because you guys understand users better, so you guys can understand what is it that this user will agree to be able to believe that yes, this decision this algorithm took is actually the right decision. Yeah. Now, coming to right and wrong, I want you guys to look at this one last video, and this is called as a trolley problem. Does anyone know about the trolley problem?
No.
Yeah. Yes or no?
Two people.
Okay. Two people. Okay, cool. So let us look at this trolley problem. What it says is that I'm not going to play a video. It's a bit complicated. Let me try.
A runaway train is heading towards 5 workers on a railway line. There's no way of warning them, but you're standing near a lever that operates some points. Switch the points, and the train goes down a spur. Trouble is, there's another worker on that bit of track too, but it's 1 fatality instead of 5. Should you do that?
So did you get the problem?
Yes.
Yeah.
Yes.
Okay. So you have two choices. One is to kill those 5 people. The other one is to kill that one person, and you have a lever in your hand. So would you change the lever to kill that one person or not? Is the question. What do you say?
No.
It's difficult to say because if you push the lever, you're basically killing someone knowingly.
If you don't push this,
But you're not saving 5 people, but then you are killing someone and you know it. Basically, you're putting a knife in
You're not doing anything is also.
Yeah, that is.
No, but you, if you take some action, then you are the murderer. If you don't, then it's not your, legally it's not your liability. You should be unbiased to these kinds of situations.
You have to do something. Not taking an action is not an option. Then what would you do?
So not taking, like not pushing the lever is also an action, right?
Exactly. Yeah. Not pushing a lever is also an action. So it's not a physical action, but it is a mental action. You have to made a mental decision, right? That you are going to not do anything.
I'll kill one person.
Sorry. Okay. Good. So now let's say that there is this other scenario that
Many people think the right thing to do would be to switch the points, to sacrifice 1 to save 5, since that produces the best outcome possible. Now imagine the train heading for the workers again. This time it can only be stopped by pushing a very large man off a bridge. His great bulk would stop the train, but he'd die. Should you do that?
so now there is no lever, but there is this fat guy. If you push him off the bridge, it will come in front of the track, and the train will hit that person, kill that person, but then the train will stop. Would you push that person or not?
Same, both of them are same.
Same logical thing. So now I can't change my answer.
If I'm pushing the lever, I'm also willing to push the button.
No, it's just it's a different situation because the fat man is not in danger of dying. Neither was no, but they were. Just because it's a fat man doesn't mean.
See, the thing is that the outcome is the same in this case. I mean, you are trying to save 5 people by killing one person, right? It can get even worse. Let's say there are 5 people and you are a doctor. There are 5 people in your hospital. Each one of them has a problem in one of their critical body parts. So one has a problem in the kidney, the other one has a problem in the heart, the third one something fourth and fifth. And these 5 people will die if you don't replace their critical body parts. And there is a completely healthy and hearty guy who just walks into the hospital for just a normal checkup. And you realize that this healthy guy, if I break him and tear him into parts, I'll be able to save 5 lives. Will you do that or not? It is the same thing, right? The same dilemma.
Absolutely.
So,
This is, of course, so here the probabilistic thing comes in actually. So the probabilistic thing might be that, like earlier, the probability that 5 guys or one guy will die was one. So, or if I change the liver, saving 5 lives, the probability was also very high. Whereas here we are not sure about the probabilities in actual case. So the error
So
adds.
yeah, I mean, these are hypothetical situations to play with our brain. So we can assume that, let's say, if I replace the liver, there is 100% chance that all of those 5 people will actually survive and live well and all that types, right? But the point of this discussion was that at times the outcomes in each case is the same actually. That you will save 5 people and you will kill one person, but the manner in which these things happen, in some cases things are socially acceptable, in some cases socially or culturally or humanly ethically acceptable, in some cases they are not. Now if AI is going to make decisions on our behalf using the system one part of the brain, someone needs to make that, write that in that piece of code, because when a doctor is going to get that decision, that decision is going to come, let's say, from an AI algorithm. Now maybe not this exact same scenario, but when decisions start coming from AI algorithms, they need to be, these decisions, that ones that we were discussing, need to be coded. And it is machine learning engineers who are going to code that, so they can actually be taken to court of law if they do something socially unacceptable. A realistic example in this domain is, which deals with machine learning, is let's say you have a self-driving car and there are 2 people. The situation is such that there are 2 people on the road and you'll have to smash against one of those. One is a 5-year-old child, the other one is a 75-year-old person. So if you had a choice, who would you smash? And this is what the algorithm needs to decide, because it is a self-driving car. It will have to turn one way or the other. There is no option anywhere, right? Now, what happens is that some societies actually say that it is better to save the 5-year-old child because that child has to give a lot to humanity throughout the entire life and so on and so forth. And therefore, the humanity will improve itself if this person serves for 50, 60 more years. On the other hand, there are some societies which say that this 70-year-old person has much more knowledge which he should be sharing with the world and experience. And therefore, I need to preserve this person so that this person can share the knowledge to the entire world, which he had gained over those 70 years. On the other hand, the 5-year-old kid has not gained anything so far. So there is no information loss there. So there is nothing right and wrong here, but from a design perspective, someone needs to actually come and start thinking about bringing in and understanding these social and cultural concepts and ethics into the AI algorithms. And that's another big area where design can actually significantly help, because with design background, people are able to understand how humans react, what is socially acceptable, what is culturally acceptable through ethnography and those kind of things. So how do you bring those considerations, and how do you in some sense author them so that algorithms can actually understand, appreciate, and then be built on top of that, is another area that um, um, these culturally sensitive problems can be brought into in the right way to the AI algorithms. So that's all I actually had, unless there are any questions, because I'm out of time. I had something else, but we can skip that piece because I'm out of time. If you have questions, we can discuss that. If you want to go through this, I can do that as well.
Right. So this question is regarding deep learning. So this year at IndiaHCA, we had this workshop where MathWorks came in and were teaching us the basics of deep learning. But other than the provided, so they were taking fruits and getting the software to identify these fruits from the pictures.
Mm-hmm.
but whenever something else was shown, they were still turning up these fruits. So it's probably a corpus related problem. So whatever they had trained the AI in, they were just returning those images. But I was wondering, how much time do you think, in your opinion, it would take for such softwares to identify everything to a 90% or 95% accuracy?
Um, yeah, I'm not well qualified to answer this as to how much time it would take because there are experts who've been thinking and looking at these. So there's something called as generalizability in AI. So currently we build systems that are very specific that can understand very well, let's say, a mammogram or let's say a radiology report. And if you show it a scene, it will not understand at all. Or the one that you said, a small system which can understand fruit and it doesn't know anything beyond it. But how do you build a general AI system that can look at everything and understand it and so on? I don't know how long, but I think it is definitely very, very far off from where we are currently. We are only replicating how a brain works in a very specific and a constrained environment. This whole concept of deep learning, I should have put that chart, but this whole concept of deep learning is based on how our brain works actually. Let me actually show you a slide. Um, Can you see this on your screen? Anatomy of a human brain.
Yeah.
Yeah. So this is called as a brain map. What it is saying is that the amount of space that different body parts um, take in our brain. So things like forearms take less space in our brain. And each body part in the brain is actually wired differently. So the way your tongue operates, I mean, the way your brain operates from the signals that come from the tongue is very different from the way your you would have heard about things like CNN, convolutional neural networks, or LSTMs, which are like long short term networks and so on, long short term memory networks. So these are trying to replicate how our brain is wired. And so I replicate the way my brain is wired for listening is that is very different from how my brain works when I have to see things, which is very different from how my brain works when I do finger movements and so on. So right now, the stage where we are is that we are building these algorithms. We first of all try and understand how the brain works. We means the neuroscientists, how the brain works in a specific scenario of being able to understand a language or being able to understand a fruit. Try and I understand that architecture, replicate that in an algorithm, and then train that algorithm using that data. If you, the kind of question that you're asking is how do you build something to understand everything? We don't even know how the brain works in all of these things, and there are a lot of ways in which one part of the brain works with the other and so on and so forth, and then replicating it becomes it is an approximation, and then training it becomes another approximation. So what we do is that we look at only specific parts of the brain and then try and replicate it. So in some sense we are kind of far.
So when we talk about interpretability and explainability in AI, but many deep learning algorithms are like sort of black box algorithms where there are hidden layers and you don't know how to interpret it or how that decision came to be. So how would that work? Like, would it be possible for certain visualization or interpretation, like 100% interpretation, in critical situations like where the doctor needs to see how this algorithm came to be?
See, we are limited by how we humans make those decisions. As I said, in all real scenarios, when human beings make uncertain decisions, if I ask you a question, why did you make a decision to join IIT Bombay? You will give me reasons, but they are not real reasons, honestly speaking. You will now try to justify the reason that you had already taken, which is a completely different process. I hinted upon that when I asked you, why did you say that this is a angry or angry woman? There, you just came up with that answer, and now you're trying to justify why that answer is. So then you look back at the image again, and then you try and figure out that maybe the hair length is so and so and so forth. If I ask you, why did you join this particular course, or why did you come to IIT, you're going to again look back and then make some weird answers and cook up some answers, which may be right also, but that's not how you arrived at that decision. And this is the way our brain works. That we I'll give you another example. So Sotheby's is a broker, real estate broker type of an agency in the US. So when they go to show houses to people who want to buy a house, they actually bake cookies in that house, because the smell of cookies make people feel more positive and happy about the house, and therefore they buy that house. If you ask those people, why did you buy that house, no one is going to say because it smelled good or I smelled cookies and so on. But what happens is that because there was a smell of cookie, you started feeling positive. And since you started feeling positive, you would feel that the window is good, ventilation is nice, and so on and so forth. So the actual reasons for making these uncertain decisions are unknown to us human beings. Of course, AI algorithms are looking at explainability, and they are figuring out ways to do that explainability, and a lot of it is, in some sense, out there in the market as well. But there's going to be a significant gap between the real reason versus the reason that is being made to sell or to convince you. The reason to convince you, yes, there are a lot of algorithms and people are working on it. And mm, I mean, in some sense, there are already solutions existing there. So there's nothing that it will come, those black boxes, it will take time to become more transparent boxes. But you should have it at the hindsight that they are still not the right reasons.
Okay, yeah, question. Okay, so sort of going back to the trolley problem. So at this point of time when it is difficult to explain what AI is doing, but we're still seeing it being applied to a lot of industries, where do you think the accountability should fall at this point?
Okay, so first of all, it is not true that the AI algorithms are still black box. As I said, there's a lot of explainability that already exists now, which is how people are using that. Whether it is correct or complete or not is questionable, but yes, explainability does exist. So since some level of explainability exists, therefore the accountability now is within that domain of explainability is lies with the people who build those algorithms and people who build those rules, and to make sure that the things are culturally correct or not in some sense. As an example, I'll just maybe show you this stuff. So this is one example of removing of taking accountability. So people who are building algorithms, they are trying to take accountability that their algorithm should not be biased, they should be gender neutral or some other neutrality um, that the society feels should be neutral. So as an example, what they do is that let's take gender neutrality. I have a job profile, and I'm trying to find which candidate is most fit for this job profile. If I look at all the past candidates, maybe let's say 90% of the candidates who had gotten this job were females. So my algorithm is going to bias towards females, and it will say that if it is a female, why don't I recommend it to this job? Because most likely this job female will get the job. but then that is bias, gender bias, right? So what I do as an algorithm builder is that I remove the um, data which talks about gender of this person. So this is called as a data obfuscation process, so that the algorithm does not take decisions based on gender because it does not even know the gender of the person. But these algorithms are smart. At times, what they do is that they can maybe decipher the gender from the name, not knowingly but unknowingly. So maybe all the names that end it with A, or most of the names that end with the character A, are actually female names, and therefore maybe that even us, without knowing it, the algorithm would have been trained that most of the people with characters A character at the end are getting this job, and that's how it got that. It starts to recommend those things. So then you start looking at the results and try and see, are my results imbalanced in some sense? So then you look at those results. And then the third way is that you try to look at um, the results and try and see if they can be argued. So which means I give 10 results, and then am I able to explain why this is the case, which means why are more people from one geography, or why are we more people from one gender or race, and so on and so forth. If I'm able to argue, that is fine. If I'm not able to argue, that means the algorithm has learned something which I do not want to show. So look at the results and then try and identify where has been the gap in some sense. So AI community itself is taking that accountability to some extent. Some of it, and defining what is right and what is wrong, comes mostly from these ethics type of committees which are now getting set up by the governments and organizations.
So I had just a quick question. So where do you think in the flowchart of this whole process of AI in design, where does a designer sort of, where should they sort of try and plug their expertise in? Because most of it still sounds a lot like a computer, something that a say coder or algorithm developer would do. But as a designer, where do they bring in their strengths in this process? Would they probably visualize the data that is there better, or
I think design in AI would need to go very deep beyond just visualizing a web page type of a stuff, because a designer knows the psychology of a human being. The AI algorithm know how the brain works, but the psychology part is something that needs to be brought in by designers. So the example that I gave of how the psychology of a human mind works when they choose a particular, let's say, partner on a dating site or a matrimony site, that psychology needs to feed in before the AI algorithm is one. So that is one part. Before the actual algorithm is built, you need to see how users are going to react and interact with those systems, because AI algorithms are dependent on what you say here. So that initial user research is actually the first step before an AI algorithm is built. The second is, which I said, is in the space of persuasive design, as to how, when this whole explainability of AI is coming in, how do you persuade a user that this decision that this black box or whatever you call it, AI system has taken, can be made to believe by the user. And all these persuasive strategies which you earlier maybe used to look at, like web pages, to make sure that the most important item is something where the eyeball would fall and so on. Here the persuasion will need to come from the fact that um, I'm going to explain this reason why the revenue of Mastercard is going to be X% in the next quarter. I'm going to explain this using 5 different ways. But what is the most persuasive way to tell that to the user is what the designers should be able to come up with and identify what persuasion strategies should work with what users and with what kind of decisions that the AI algorithm has taken. And the third one is in terms of cultural understanding, and bringing that cultural understanding so that these algorithms can be designed in a much more socially and culturally acceptable manner. So those guidelines based on which we'll build these algorithms will also need to come from design research. So I think it is far deeper in the design requirement in AI is far deeper than what you would see in terms of building a mobile application, getting a person to click here versus click there, and so on.
So, hi Nitendra. I had two questions. So this is my system 2 speaking. Uh, so you asked actually, why do students in IDC, why haven't they heard of persuasive design principles by BJ Fogg, for example? That's a lot of work on persuasive design. In fact, this has been actually a stance of IDC School of Design ever since our founding, almost. Like we just celebrated our golden jubilee last month. So for 50 years, we've actually taken this stance that is. So if you probably at that time it was a system 1 decision that we will actually not go in this space of advertising. So in fact, traditionally, IDC has not worked at all, I would say, in the space of advertising or any form of persuasion and so on. And even a lot of work in the area of web development and so on. Again, a lot of the emphasis has been actually to do in areas other than persuading people to click on buttons or something, basically. So that's sort of been, in some sense, our focus for a while. So in that sense, my system 2 is justifying that, it is a good thing that students here have not heard of BJ Fogg, in some sense. But, okay, so that was a sort of a system 2 thingy. And I actually also had a system 1 question for you. So, I mean, this is also a little bit practical in the sense that maybe it can help us when we edit out the video that we have recorded today, which is, were both calls fake calls, or only the second call was a fake call?
Actually, I was intending to do only the second one, but the first one unfortunately came before the second one, and that was the real one. So I could.
So, but that set it up very nicely, actually, and it really got us. I mean, set up the second call also very nicely. Like, first one was like a rehearsal. Okay, so this is how things happen, and then the second one was really. That's why I think all of us got that.
You had some muted, like, so we thought something serious.
Yeah. So thank you very much today for spending time with us. It was really lovely to have you here, and we look forward to meeting you again. We should probably meet more often than we've been meeting in recent times. So maybe you should think about coming down to IDC at some stage, or maybe you should come to India or something like that. So looking forward to meeting you again. Thank you very much.
Sure, Professor. Thank you so much.
Thank you. Thank you very much. Bye.